Holocene has ended. What we do now and in the next few years will profoundly affect the next few thousand years. The only conditions modern humans have ever known so far are change, and changing fast. Nothing stays the same on this planet. Everything changes. The Earth is going into one of these jumps, and you don't know what is going to be on the other side of those jumps. The Earth is always jumping. Things move on this planet. Things are not still. Everything is turning on as it begins to run out of fuel. The sun will simply fade away to nothing. Its core will collapse. And the extra heat this generates will cause its outer layers to expand. The sun is now dead. Its remains slowly cooling in the freezing temperatures of deep space. The fate of the sun is the same as for all stars. One day they must all eventually die, and the cosmos will be plunged into eternal nights. All stars eventually will run out of fuel. The temperature of the universe drops, and the stars one by one in the night sky will turn off. And there will be no more new stars created. Hence, the closure of the universe will not manifest as a dramatic explosion, but rather as a subdued murmur. It won't conclude in flames, but in a state devoid of the fuel necessary for combustion. The faint radiance of a white dwarf emanates from the residual warmth lingering after its energy source has been extinguished. When observed from Earth's current vantage point, this radiance would merely match the luminosity of a full moon on a clear night. Within the bleak emptiness, speckled with deceased stars and black holes, the feeble gleam of white dwarfs will offer the sole source of light. In certain aspects, this scenario resembles a spectral universe, a realm of remnants and zombie-likes, czars that will guide us into the forthcoming era. The ultimate destiny of those last stars will be that of a black dwarf. These white dwarfs will have cooled to such an extent that they emit only the faintest traces of heat and light. Black dwarfs stand as dark, densely packed remnants comprised of degenerate matter. They resemble little more than the remnants left behind by stars, where the constituent atoms have been compressed to such an extent that black dwarfs are 1,000,000 times denser than our sun. The journey for stars to reach this particular state is of significant duration, and according to current understanding, it is believed that there are no black dwarfs existing in the universe at present. Our rhythm of life is intricately linked to the available energy accessible to us in the present moment. One can conceive of conscious living systems that operate at markedly different tempos, thereby stretching out their existence far beyond conventional expectations. It's feasible to envision a living system in which having a single thought every 10 trillion years would be deemed ordinary. Even in the event of the eventual decline of our current life form, it's conceivable that at some undetermined point in the distant future, a random fluctuation might transpire, facilitating the resurgence of intelligent life for a brief span. So you might have islands of time of intelligence, a proton or one of the fundamental building blocks of atomic matter. What makes us can just spontaneously fall apart. Any material that evades the pull of a black hole eventually dies away as its protons disintegrate. The matter inside black dwarfs the last matter in the universe, will eventually evaporate away and be carried off into the void as radiation, leaving absolutely nothing behind. With the black dwarfs gone, there won't be a single atom of matter left. All that will remain of our once rich cosmos will be particles of light in black holes. The arrow of time creates a bright window of the universe's adolescence, during which life is possible. However, this window remains open for a relatively short span, merely constituting a fraction of the universe's lifespan. This measurement stretches from its inception to the point of the final evaporation of the last remaining black hole. Life in the familiar form we understand is viable for just a minuscule fraction, 1,000th of a billion, 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 billionth of a percent of the universe's existence. Remarkably, black holes assume the role of the universe's primary building blocks. In essence, a galaxy will take on the configuration of a supermassive black hole at its core, orbited by smaller black holes. These zombie galaxies, brimming with black holes, continue to undergo transformation and development. They will mutually influence one another, leading to their enlargement. Perhaps they will eventually be drawn into the supermassive black hole, thereby augmenting its size. The universe will continue to be a captivating and dynamic realm, though the time spans involved are now measured in trillions of years rather than thousands or millions. Black holes possess the capacity to reverberate through the fabric of space-time, akin to mallets striking a drum. And they emit a distinctly identifiable resonance. Envision a scenario where two black holes, having shared an extensive existence, conclude their journeys by orbiting each other, traversing thousands of kilometers within a fraction of a second. In this process, they generate a lingering spatial oscillation, a tangible wave coursing through the very fabric of space-time. Space undergoes compression and expansion as this phenomenon emanates from the impact of these black holes on the universe. Indeed, those phenomena are none other than gravitational waves, and they can be understood as the audible echoes of space itself. These waves emanate from the black holes, propagating outward at the speed of light, gradually merging and culminating in the formation of a solitary, rotating, and tranquil black hole. Imagine standing in proximity to this event. Your ears would resonate with the stretching and compressing of space. You would essentially perceive these gravitational waves as sound. Picture a scenario where a less massive black hole is drawn toward an immensely heavy black hole. The sound you're perceiving corresponds to the lighter black hole, impacting space. With each approach and subsequent fall, the rhythm accelerates and the resonance intensifies. In the past, scientists speculated that black holes might serve as portals, but even they will eventually meet their end. Now we're contemplating timeframes on an inconceivable scale, quadrillions of years into the future. Over such immense timescales, even black holes succumb to the effects of quantum mechanics. Space brims with virtual particles, constantly popping in and out of existence in pairs, only to separate and reunite, annihilating each other when encountering a black hole. In this process, one particle from a virtual pair might be drawn into the black hole, while the other remains unpaired, lacking a counterpart for mutual annihilation. This unpaired particle manifests as radiation emitted by the black hole. Consequently, black holes are not eternal entities. They experience an evaporation process that intensifies over time until they ultimately vanish in a colossal burst. Quantum mechanics permits particles and radiation to escape even from the clutches of a black hole, marking a departure from the notion of their absolute captivity. Throughout history, philosophers and poets have pondered whether the world will meet its end through fire or ice. Today, we can provide an answer based on the latest evidence. Contrary to slowing down, the universe is actually accelerating at an uncontrollable pace. It appears that the universe's ultimate fate will be one of ice. Even in the vast expanse of empty space that spans trillions upon trillions of years, energy is present within every cubic centimeter. This energy persists in space itself, irrespective of the presence or absence of particles, matter, or radiation. According to Einstein's principles, this energy exerts a propulsive force on the universe. The enigmatic factor behind this acceleration is referred to as dark energy. This mysterious entity constitutes the predominant component of the universe, making up nearly 3/4 of its matter. Energy content. Astonishingly, the true nature of dark energy remains unknown. Unlike ordinary matter or radiation, dark energy doesn't dissipate as the universe expands. This attribute carries significant implications for the universe's future. If dark energy continues to dominate and exert its repulsive force, the universe will continue expanding perpetually. And its expansion will accelerate at an increasingly rapid rate with the passage of time. This could lead to a universe racing away uncontrollably. Around 70 of the universe's energy is present within the void of space, a phenomenon that eludes our comprehension. Nevertheless, we possess an understanding of the potential outcome if this energy persists. A scenario emerges in which the universe transforms into a frigid, lightless, and desolate expanse. A possible future that hinges on our grasp of dark energy's fundamental nature, a subject currently beyond our reach. Anticipating the forthcoming events proves elusive. Even comprehending our own origins remains an enigma. This inherent curiosity and the desire to explore prompt us to delve into and study this domain. While indications point to the likelihood of a future marked by a cold, lifeless cosmos, a pertinent question arises. Could this conclusion pave the way for a fresh inception? Concepts exist wherein the eventual fate of our universe could be intertwined in some manner with the dawn of a novel world. The meticulous calculations and equations have been meticulously worked out. They appear to propose that through the utilization of an immensely powerful particle accelerator, it might be conceivable to create an avenue, a nascent universe on the brink of universal demise. Yet, this proposition stands as a solitary potential within its scope. Additionally, this line of thought gives rise to an enthralling hypothesis, albeit speculative, suggesting that any universe harboring intelligent life could potentially generate progeny universes. A survival mechanism birthing escape pods of sorts and proliferating realms anew. Thus, an evolutionary process could conceivably unfold across the various universes within the multiverse. The principle of survival of the fittest might apply, determining the course of events. Universes lacking intelligent life would remain barren, incapable of producing offspring. Conversely, universes characterized by moderate temperatures and stars, akin to our own, could give rise to civilizations with the potential to initiate the creation of child universes. Over an immense expanse of time, these universes could propagate and multiply. Even the phenomenon of black hole evaporation would transpire, leading to a universe comprised solely of photons, gradually converging toward a uniform temperature as cosmic expansion drives them closer to absolute zero. Once the very last vestiges of the ultimate stars undergo complete decay and fade into nothingness, and all matter reaches equilibrium in temperature, the grand narrative of the universe culminates. In a unique twist, the universe will attain a state of permanence and unchanging stability. Entropy, the measure of disorder, finally reaches a plateau as the universe's complexity cannot further diminish. A state of inertia takes over, and this state of equilibrium persists infinitely into the future. If you like this video, put a like and subscribe to the channel.